मैंने यूज़ नहीं किया, मेरे लैपटॉप में है स्क्रीन
Uh, Hello everyone. So I hope my screen is visible and I'm so sorry for all the technical glitch, and I have done the last minute checking, but it seems there was some issue. Please confirm me if you guys are able to see my presentation.
Yes, ma'am.
Okay. So the today's class is Introduction to Machine Learning, and my name is Kaushiki Chaparia. I'm a PhD student of IIT Bombay, and the topic for today is probability and linear algebra problems. So for machine learning, probability and linear algebra problems are such which will help you in knowing how the algorithms work. So machine learning is just not about codings and how things are done with this. It's more of how the algorithms work. What is the mathematics behind it? Before that, let's go with the some administrative things I would like to notify. So whatever is written will be made available in PDF format. So please do not focus on writing or taking notes. And there are 4 p.m. RFTS, and my session will be on Saturdays 3 to 4 p.m. We usually do some problem solving methods. So today's will be more of mathematical problem solving, that is probability and linear algebra. I will definitely in the coming classes, I'll be going with the programming, like how Python works, how you can do the coding, and what are the different Python libraries and packages which you can use for machine learning. If you're anytime see, I am sharing my screen right now, so I'm unable to see the chat. So please feel free to interrupt me and ask me doubt anywhere whenever you feel. And in case if I and you get dropped, which is very normal I guess, and we just have inquired right now, so it's just fine, don't panic, join again. You can interrupt me, you can ask me to repeat again. Hope I'm clear. And I really want this sessions to be interactive, so you can just unmute yourself and ask me any doubts. Starting with that. So why probability and why we need probability? So probability basically deals with what is uncertain. Like we don't know if it will rain tomorrow, or we don't know what is going to happen in the future. So to predict, it's not about any astrology, it's more of how you can deal with mathematics to know the uncertainty. That is what probability is. We always say that 50-50 chance. So that what probability is. So for a probability, I have put few questions, like if you need to know in an image how many passenger planes have passed and how to identify that object. You can say, okay, if you will say, okay, I think among 10 passenger planes, I have seen 8 of them is planes which is going to US. So that out of 8 to 10 is your 80% probability, right? Similarly, if you have to say the crop yielded in a particular season, so what is the probability of that? These are mere examples where you can use your probability concept. The most likely is COVID-19 to start decreasing, where every mathematician ended up using probability to find how and what, because this is what probability deals with, the uncertainty, which is not sure of. So after that, we will go. Yeah, anyone have some question? Please go ahead. Okay, let me see. Someone is. Okay. So yeah, after this, we will be doing some problems related to probability. I have taken up 3 questions, starting with mere basic to little bit advanced. So the first question is, you draw one card from a deck of cards, and we all know, like a deck of card, uh, any card, if you draw a card from a deck of card, what is the probability that you draw an ace? So I would like to hear from you guys.
1
by
by
4.
50.
1 by 13.
1
by 4.
Okay, so any of you can please explain me how you have done this?
4 by
A
52 because
a
there are
deck of
52
cards have
cards.
Yeah, okay, yeah, deck of
there
cards
are
are
four aces. So
exactly.
4 by 52 is 1 by 13.
Okay, okay. And anyone else who I heard another voice, I guess. Like there were some other answers. Please go ahead.
So on the numerator, it is total possible outcomes. On the denominator, we have total outcomes. So possible outcomes are 4
Yeah,
on
yeah.
the numerator. Denominator has 52, total number of outcomes. So it is 4 by 52 and
Yeah.
1 by 13.
Great, great. Okay. So exactly. So number of cards 52 and aces are 4. If we will take four different shades. So 4 by 52 and it's the easiest one. So this is one of the example I just wanted to tell you guys how the probability works. And this is the like very basic example which we all have, I think, have done this kind of questions in our 10th and 12th. Scaling up to it, so the next question is, what's the probability that you draw two aces when you draw two cards from the deck? Please take your time. I'll give you 2 minutes. Take your time and please, whosoever comes with any solution, I need with some explanation, please.
Excuse me, ma'am.
Yeah, please go ahead.
Is the answer 2 by 221?
Okay, so I would like to know what is your justification.
The thing is,
Yeah.
they are asking the probability that you pick two aces. So there are a total of four possibilities, and
Okay.
from four you can select two. That is 4C2. That will give you 6. And
Okay.
the total outcome is from 52 cards. You have to select two cards. That is 52C2. That is
Okay.
that's a value. So when you divide these two, you will
Mm-hmm.
simplify it to 2 by 221.
Okay, great. So you have used your combination and permutation concept.
Yeah,
Okay.
exactly.
Okay, great. Anyone else? Like we will see what's the answer is. I really want someone else to try it out. Yeah, please go ahead.
Okay, so if I think it naturally that first I can draw among four aces and then there is 52 cards, that is the first trial. And then in second, after I draw one of these aces, I have three aces left and 51 cards left. And so I have 3 by 51. So 4 by 52 and the 3 by 51 which comes out to 1 by 220.
Okay. Anyone else? Anyone else would like to add something? Okay. So, uh, first thing first. If one have to draw ace on first draw, so that will be 4 by 52, right? Because there are four aces in the deck, which we have already solved in our previous question. Out of 52 cards, there are four aces. One have already drawn. End of story. Now, the second thing comes. See, I please let me know your name. The one who have used combination and permutation. Actually, it's a very good analogy to do. But over here, we are not dealing with permutation and combination comes when we have to deal with positions or which card needed to be drawn first and which card needed to be drawn second. Over here, simply the question is, you have to do two aces out of all the deck cards. So, but when you draw one card, you're not going to put it back. So, when you draw first,
लग रहा है
sorry, yeah, sorry, someone is speaking. Okay. So, if you draw one card, so four aces out of 52 cards, that is one. Now, there are three aces left out of 51 cards. So, this is how you have calculated this probability questions.
Ma'am, but in question you did not mention that we withdraw one by one or simultaneously.
See, the question is, what's the probability that you draw two aces when you draw two cards from the deck? So, the question, you have a set of 52 cards, and in that, I'm just asking, you have taken two cards. So that means obviously you will be taking two cards simultaneously, right? So the question was, those two cards, what is the probability that those two cards belong to two aces? That was the question. So when you are taking those two cards, you're not taking, you're seeing both the cards. So you have to check it one by one, right? I hope I'm making clear. If not, then please ask me the question.
Yes, ma'am, it's clear.
Yeah, okay.
Clear, ma'am.
Yeah, great. So going ahead, this is the question where your and concept comes in with the probability. Now, there is one very important theorem in probability, that is Bayes' theorem. So what we do is, in that we, like how I have shown in the previous example, that the two outcomes can be related to each other. For example, if I'll just go back to the previous question. So the first deck which has been taken out is somehow is related to the second one, because you cannot find the probability for the second ace until unless you know that first have already been drawn. That is how you're reducing the number of cards in your deck, right? So that is mutual interrelation. So Bayes theorem does that. Over here we calculate how mutually this probability is related. So over here A and B are two independent events. Independent events I meant is, A is one event, for example tossing of coin, and B is another event where we have to identify number of coins or number of heads. So these are two mutual independent coins. So related to that, I'll be giving you a question, that is, if you can read the question and if you can go through the question. So we will go one step ahead. So just read the question and let me know if you are able to understand this question. If not, then I'll try to make you understand this question, and then we will go for the solution. And please take your time.
Is it 0.999?
Okay, we'll go. I think you're okay. So first go with the question. So the question is, if HIV has a prevalence of 3% in San Francisco and a particular HIV test has a false positive rate. So the important part is false positive rate, which means false positive. There are two terminologies over here. One is false positive rate and one is false negative rate. False positive rate means a person is positive, but it is showing that it's not true. And false negative rate is a person is negative, but it's showing it's positive. If I'll simplify it. For example, okay, we'll take the HIV positive test case. So if a person goes to a hospital and he was actually positive, but the test came as negative. So that is what is false. What it will be, false positive rate or negative rate?
False positive.
False positive.
Exactly. And if a person goes there and he get tested, but he was not actually positive, but the result came positive, that is false
Negative.
Exactly. So these are two terminologies which is most important over here. And in this scenario, the important part is if he is actually positive but the result comes negative, right? So that's probability should be less. So the question is, what is the probability that a random person who tests positive is actually infected? Means true positive. Like he is positive and actually is infected. Okay, so this is what why our question is. So if we'll go to Bayes theorem again, so this A and B are two individual event which I told, and how we are going to solve using Bayes theorem, I'll show you. See, so we have two things. One is true positive and one is test positive, right? Which where actually he is positive and another is he has been tested positive, right? So uh, I think someone have given me some answer. So if you want to verify your answer with this, and if someone would like to, like if someone have got the same answer, I would love to hear their explanation. Although I've already shown the answer, but if someone wants to explain it, I'll be happy. Okay. I think someone gave me some answers. I am audible, right? Hello.
Yes, ma'am.
Yes, audible.
Okay. Please, yeah, like let me know if someone wants to uh, tell anything related to this, or anyway I'll going to explain, but yeah. Okay.
Yeah, so in the
Yeah,
denominator we have being positive and testing positive. So multiply
exactly.
basically the 3% with the next thing,
Yeah,
and then being negative and testing positive. So this
exactly.
are in the denominator, and the total probability is on the numerator.
Exactly. So I'll go back to the question. So over here, the question was a particular HIV test has a false positive rate of 0.001. So if false positive rate is 0.001, so what will be your true positive rate? 1 minus 0.001, right?
Yeah.
That will be your true positive rate. Similarly, false negative rate of 0.01. So 1 minus 0.01. And why I'm considering 1? So no one, like, if someone would like to say why I'm just taking 1 and not any another number. Why we have to take 1?
Because the total
Ma'am, because the
probability.
total probability is always equals to 1.
That is, yeah, that's it. It's a very basic thing, but everyone should know. That's why I just inquired again. So this is one thing, right? And the total HIV prevalence, this means the percentage of HIV cases are 3%, right? So our question was to test the positive rate. So if we'll go back to the solution over here, we have to, this is what we have to find, that is true positive when they are actually tested positive and it is true. This is what we have to find. Like if a person goes, he has been tested positive and he is actually positive. So to find that, the using Bayes theorem, we are taking true positive when tested positive into true positive. This true positive is already given, that is 30%, right? Sorry, 3%, that is 0.03. And he's actually true positive when tested positive. We have already seen this where that was 0.01 false negative rate. Similarly, over here, because our Bayes theorem is A by B into PB, that means if a if we need to find the probability of A and B, that we can find probability of B by A into probability of B A, that is another event, divided by probability of B. So using this, I have calculated true positive when test positive is given. So there is a difference between this. What we have to find is it has been tested positive when it is actually true, and in the numerator it is actually true when it is tested positive. These are two different criteria. Okay, so this is the solution for the HIV positive case. Let me know if anyone have any doubt, or I can move forward.
Ma'am, kindly show that base formula.
Sure, sure. See,
Ma'am, can we solve this by using conditional also?
exactly. That's where I was coming to. We can solve it via conditional as well, but using conditional, you have to go with so many steps, right? So this is where Bayes theorem comes into picture. In
Uh,
Bayes
but,
theorem, yeah.
but ma'am, conditional by using conditional, it become little bit easier for the calculation.
Okay, so if you think so, I think you should go ahead with that. But personally, I feel because in conditional probability, you have to find all the conditions where,
Yeah.
yeah. So if you have to theoretically write all the conditions. I should have given the conditional answers as well with this. But with the conditional, the scenario will be where you have to mention all the conditions when it is true, when it is false, when it is false positive, when it is false negative, when it is true positive, when it's true negative. So all these 6 parameters needed to be there. In Bayes theorem, we just need to know if we have to find, for example, if you can see the second one, therefore the simplified one. So when the probability of B is given, we have to find the probability of A. So how we can find? Given the probability of A with B into probability of A divided by probability of B, where probability B and probability A are two different individual events. So using this, I have find, given the test was positive, what is the probability that is true positive? To find that, we have done given true positive when it is tested positive. So we already know this factor. How? Because we were having the factor of false negative when tested positive. That was 0.01. With that, we calculated 0.99. The probability of true positive was already given, that was 30%, with that 0.03. Similarly, this is the same formula, and true negative when it was actually positive, so that was given 0.001, that in the terms of false negative, right? And P true negative. So how we find negative? We have already true positive, that is 30%, so the 3%, so the remaining 97% will be negative. So this is how we have solved them using Bayes rule. I hope I'm clear so that I can move forward with linear algebra questions.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay.
Excuse me, ma'am.
Yeah, please go ahead.
Please admit Nihal Gupta. He's in the lobby waiting.
Oh, I'm so sorry. Actually, I have to go back again and again. So yeah.
Yes, ma'am. Network issue here was disconnected.
Okay. Thank you for letting me know. Yeah.
Ma'am, can you please show the question please?
Okay, I think there's someone else. Okay. So we can move ahead. Okay, so this sums up the probability questions and how probability is going to be implemented in machine learning. We will see in the future where we will be going through different algorithms and how the probability concepts comes into picture in terms of um, like softmax equations, or in terms of, you know, to locate any object. So we'll see how practically probability is being used with machine learning. So speaking of that, let's move ahead with next topic, that is linear algebra. So linear algebra is basically how our eigenvectors and our eigenvalues deals with. So there are few of all the things I have taken out 6 special properties or 6 special points of linear algebra that is needed to cover the basics of linear algebra. So if we are saying A is a numerical factor and X is an unknown identity, then the eigenvector of X keeps the same direction when multiplied by A. So over here, lambda is a factor which is when multiplied with an unknown factor X can give a factor that is similar to the A into X. This is one thing. Second thing is Ax is equals to lambda x also says that determinant of A minus lambda I, where I is my identity matrix, will be 0. This determines n eigenvalues. I would like to know, anyone over here doesn't know the concept of determinant or identity matrices or eigenvectors or eigenvalues, please let me know. Okay, hope I'm audible. So the question was, if any of you over here don't know the concept of determinant, matrices, identity matrices, eigenvalues or eigenvectors, please let me know.
I don't know, ma'am. Can you please explain?
So what, like exactly you don't know about anything related to, yeah, please.
Yeah. I know, ma'am, but I forgot. Can you please tell me once again?
Sure.
What is
So
what? Yeah.
yeah, sure. So matrices are basically the numbers where we deal with 3 cross 3 matrices or 2 cross 2 matrices where the rows and columns are there. Identity matrices is something which is dealing with if we are talking about 3 cross 3 identity matrices, that is will be 1 0 0 0 1 0 0 0 1. This is one identity matrices. Over here what we are dealing with is linear algebra where our matrices are involved. In that, we needed to find eigenvectors and eigenvalues. So the questions which I'll be covering up will consist of how eigenvalues or eigenvectors are calculated. Okay, so A is one of a matrix that can be any matrix or which consists of any dimension. And if we need to find the eigenvalues or eigenvectors of these matrices, then how we can determine those things. So that is what linear algebra questions over here is. In that, what I'm saying is lambda is a value. It's just a lambda is a value which we don't know, is an unknown identity value. I is an identity matrix and A is a different matrix. So when we find the determinant of A minus lambda I, that and if it is equals to 0, we will be able to find what lambda consists of. And that is how we find our eigenvalues. Okay. So this is a property of matrices, or we can say identity matrices, with the help of which we calculate our eigenvalues. Now the eigenvalues of A square. Now what A square means is that 2 where our A is a matrix. So if we multiply two matrices, and inverse of a matrices is always lambda square and lambda inverse, which will be for the same eigenvectors. Okay. The sum of lambdas equals the sum down the main diagonal of A. So if we have a matrices, for example, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the main diagonal matrices will always give the trace. So if we'll do the summation of those diagonal matrices, that will give the trace of our lambda. And the product of the lambdas equal the determinant of A. So if we can find the determinant of that matrix A, we can find the product of lambdas. So projection P, reflections R, 90-degree rotations Q have special eigenvalues. So these are all defined special eigenvalues for projection P, reflections R, and if we do the rotations of 90 degree, where I is my imaginary number. So it is 1, 0, minus 1, I and minus I. Singular matrices will always have lambda is equals to 0. So if a question says, for example, if a question is that A is a singular matrices, that means that lambda will be 0. triangular matrices have lambdas on their diagonal. Special properties of a matrix lead to special eigenvalues and eigenvectors. That is a major theme of this chapter. Okay. So dealing with that, I have just put one question for linear algebra. We'll take time to solve this. So let's do part by part. So find the eigenvalues and eigenvector of A and A square. So we have a matrix A and its multiplication of A and A, that is A square, is already given. If we have to find the eigenvalues of A and A square and A inverse and A plus 4 1. So these are the questions. So if any one of you want to give it a try, please go ahead. In further steps, I will definitely going to make you solve this question and I'll let you know. So please note down the question and please do the solution, because unless you will try with your own hand, you're not going to get it.
Eigenvalue of A is 2 comma 2,
Okay.
and eigenvalue of A square is 5 comma 5. Eigenvalue of A inverse is 1 by 2, 1 by 2, and eigenvalue of A plus 4 is 6 comma 6.
Okay, great. So just okay. So just let's wait for other people. Let's see what they come up with.
Can you please put up the question once more?
Yeah, sure. So sorry, just a minute. I was trying to connect it with yeah, so this is the question. Okay, should we move ahead with the solution? Okay, so what we have discussed was here. Okay, so this was my a matrix A and determinant. So we have to calculate what A. Yeah, so we have to find A minus lambda I. This is how we calculate our determinant, right? So to calculate A minus lambda I, we have already A, which is 2 minus 1 minus 1, 2. This is A minus I is 1, 0, 0, 1 and lambda. So solving this, we have got 2 minus lambda minus 1 minus 1, 2 minus lambda. This is what determinant of A minus lambda is, right? So we all know if we have to according to the property which we have gone ahead, right? So if we have to find the eigenvalues, simply we have to say determinant of A minus lambda I is equals to 0. So this was the most important step to identify or to calculate our eigenvalues. So we have got 2 minus lambda I minus 1 minus 1 2 minus lambda I. So to find the determinants, what we do is we multiply these two, right, and these two. This is how we do, right? So solving that, we have got lambda square minus 4 lambda plus 3. Does anyone want me to solve the determinant of a minus lambda I? Because over here I have just shown the equation. If you want, I can go ahead with that.
That's fine. You can.
Sorry?
It's fine. We can go ahead. Yeah.
Yeah, sure. So this is lambda square minus 4 lambda plus 3 is equals to 0. So using this, we have done the factorization and we got the solution. We have got two eigenvalues. That is lambda 1 is equals to 1, which is this, and lambda 2 is equals to 3. Okay. So now we have to find the eigenvectors. What we have find is eigenvalues.
What is trace? Like
Okay.
Where it is given for the trace.
Okay.
The
Okay.
sum.
So the trace. Okay. I'll just go again to this. Can you read point number 4? Just read point number 4. So the trace is the main diagonal. So when we have to calculate the sum of the lambdas equals to the sum down the main diagonal of A. So this is what it is called as trace. So over here, what that means is, in any matrices, its diagonal, main diagonal sum is calculated as trace, right?
Okay, so this is a property
so
that
exactly. So what I meant is, if you directly have sorry for this. Yeah, so if you directly have to calculate what will be, or you have to validate the eigenvalues what you have uh, uh, calculated is correct. So this is how it is done. So
okay.
2 plus 2 is the main diagonal. Sorry. Yeah, 2 plus 2 is the main diagonal, which gives you 4,
Okay,
right?
okay,
And
okay,
over here, if we have calculated lambda 1 is equals to 1 and lambda 2 is equals to 3. So if you do the summation, this also gives you 4. So this validates that the eigenvalues what we have calculated is true or is correct. We have not done any mistake. So you will ask me why can't we just identify what will be our eigenvalues with this itself? We cannot do that because we need to find the eigenvalues separately to calculate the eigenvectors.
okay.
I'll tell you how it is. So in this case, 2 plus 2 is the trace. If it is a 3 cross 3 matrices, for example, if I take a, so if I'm taking 2, 3, I'm so sorry for this. Okay. Yeah. So I have 1, 2, 3, 4, 5. This is a 3 cross 3 matrix. 8 and 9. So over here, if I have to find the trace of a matrix, so that will be the summation of 1, 5 and 9, because that is considered as my main diagonal. Am I clear?
Yes.
Yeah. So going ahead, the eigenvectors, now we have to find the eigenvectors. So we have two eigenvalues, lambda is equals to 1 and lambda is equals to 3. So to identify eigenvectors, we will be calculating with this a minus lambda I into x. So this x will be giving me my eigenvectors. Okay. So how we are doing is, a minus lambda is putting the values of lambda, a minus ix, and putting the values of lambda, a minus 3ix. So this is a matrices we already have. I is my identity. Solving this, I will be getting 1 minus. I hope I'm clear how I'm getting this matrix. So this matrix have come from solving this, a minus I. That is, a is a matrix, I is the identity matrix. Solving this. Yeah. So, and xy is my two eigenvectors which I have to identify. So using this property, ax is equals to lambda x, a minus lambda I x is equals to 0 gives the eigenvalue as 1, 1. Similarly, a minus 3ix gives the vector of 1 and -1.
Ma'am, how it give 1, 1 and x1?
Sorry, what?
Ma'am, how the
So, okay,
eigenvector
okay.
x1?
So, you know the multiplication, right? So, if this multiplication, x into 1 is x, I have to just do the equations. X into 1 is equals to x, y into -1 will be minus y. I hope you guys know this, no?
Yes, ma'am, we can solve this
Isn't it?
two
Yeah.
matrices, but how does x1 equals to 1, 1?
Because when you will solve it, see, your equation will be x minus y and minus x plus y, right? When you will
Yes,
x minus y is equals to 0 or minus x plus y is equals to 0. If you will solve them, that will be x is equals to y. So that can be any values that where x is will be equals to y. So over here we have to find the values of x and y. This is what we
okay,
have to
ma'am.
find. You got it?
Understand.
So that can
Yes,
be
ma'am.
even 2, 2, 3, 3, 4, 4, anything. So the no, the
Ma'am, 1 is just an example. We can also take 2.
exactly, that's what I meant, right?
Okay.
Similarly, for this thing,
Thank
when
you.
we have calculated minus x and plus y is equals to 0. So the equation is minus x plus y is equals to 0, right? So y is equals to minus x minus y. So that is y is equals to minus x. So that is why we have 1 and -1, right?
Yes, ma'am.
I hope I'm clear. So this
Yes,
is
ma'am.
how we calculate eigenvectors and eigenvalues. So how eigenvectors and eigenvalues are going to be used in machine learning, and how, like during our algorithms, that again we will see in our nearby classes. So I think this is end of my session for today. Please let me know. We have still 8 minutes left. And if you have any doubts related to today's class, please let me know.
Ma'am, excuse me, ma'am.
Yeah, please go ahead. Just
Ma'am, will you share this PDF with us?
yeah, definitely I'm going to share this PDF.
Okay, ma'am. Thank you.
Yeah. So these are just examples which I have come up with. If you guys have any other questions, other problem to be solved, please let me know.
Ma'am, actually, I have
Ma'am,
one
I have
doubt.
one doubt.
Can you go ahead one by one? Please go ahead. Okay.
Okay, I'm going ahead.
Yeah, thank you.
Okay, so as I was saying, as we discussed false positive and false negative rates today,
Yeah.
I have a little doubt about the definition that
Yeah, yeah.
when we are saying false positive rates, is it mean that the result came falsely positive so that the person is actually negative?
See, false positive rate and false negative rate. So it's a person went to a hospital, he get himself tested, he should, and he is negative, but his result came positive. So that is false positive rate, right? False negative rate is he is actually positive, but the result came negative. So that is false negative rate. You getting it?
Right, and now this clear.
Doubts? Please go ahead.
Yes, ma'am. Ma'am, not regarding today's session. I have one
Yeah.
doubt regarding that course.
Yeah.
But in that course, we will be mainly discuss about that mathematics part of machine learning, or we will learn some type of code.
Definitely not. Definitely not. See, for machine learning, mathematics is a pillar, is a base. So until unless your base is strong, we cannot go ahead with machine learning. Machine learning deals with mathematics formulas. So to enter and to know the concept of machine learning, you have to know how the mathematics behind it and how the algorithms that is being developed in it works. For example, when we will go ahead, there is a terminology called softmax classification. So softmax classification deals totally with the our probability things. So you should know how probability works with what is probability and how we deals with uncertainty and how we are going to use it in machine learning. So this is one part. So that is for today's session, and today is the first class. So we have thought of giving you some hands-on session on machine learning's prerequisite. So these are basically prerequisite of machine learning. In the future classes, we'll be going with the coding sessions as well, and other doubt clearing sessions, whichever you guys would want to.
Okay.
Hello, ma'am.
Yeah, please go ahead.
In the first, sir discuss about a loss function. Can you please describe what is the usage of loss function?
Okay, so loss function comes with the machine learning part. So when we are dealing with neurons, and when we have to do the weight biasing, so there are some for like functions which are not updated, or there is some loss. So that is where loss function comes in. So it's a pretty much huge topic in itself. So I would like to discuss it in next class, where more concepts will be come into picture, because today is just the week 1 and first session. So let's keep it to the prerequisite of machine learning and mathematics part. So if that is fine.
Okay.
Yeah, thank you.
Hello, ma'am. I have a doubt. Ma'am, you showed a 2 by 2 matrix, right, ma'am? In that, the addition of the main diagonal is trace, and the product of the main diagonal is a determinant.
Exactly.
So, why 2 comma 2 can't be the eigenvalues of that particular matrix?
See, those 2 comma 2, okay, the property is that summation of main diagonal will be your the lambda one. So okay, so you're getting confused. One thing, we cannot take this thing because it is nowhere written the property that this can be one eigenvalue and this can be one eigenvalue. The simple thing is that summation of these two will be equal to the eigenvalues which we have calculated, right? So
Yeah,
if we
yeah,
are taking 2 and 2, that is, we are just generating some numbers, so that will not be correct, right?
yeah, yes, ma'am.
Yeah.
Okay, got it. And in the base theorem problem, the concept is like the probability that is asked divided by the total probability. Is that what you mean in the solution, ma'am? Yes, ma'am.
Okay.
Yes.
Yeah, so the question was, see, this dash you can see, this means it's a division. So it means this has already been given, that is, the person has already been tested positive. What is the probability that it is true? That was the question.
Yeah,
Yeah.
yes.
So yeah, this is what we have to. So I come again, please repeat your question.
So the formula which is given, ma'am,
Yeah.
probability of true plus slash test plus is equal to one formula is written.
Yeah.
So the concept behind that is the probability that is asked divided by the total probability. Does it?
Exactly.
Yeah.
Exactly.
Okay.
Yeah.
Yeah, ma'am. Thank you.
Okay.
Hello.
Yeah, please go ahead.
Ma'am, so my doubt is about the loss function. So we like sir talked about squared errors.
Yeah.
Then he given a formula like we are basically what we are doing in modeling is we are creating a function. So we pass the input and it should give desirable output. So like it's given a function f. So expected prediction error, like so expected prediction error f, and then there is an expectation of y minus f of x square. So
Okay.
I'm not understanding actually, like squared error is basically what, like we are given different points and we are like in the line we are square, like we are just adding the squares, like we are taking their square and adding, like how much prediction error it is give the line is apart from the actual point. So my
Exactly.
doubt is what is expectation doing here, like the probability
Okay.
concept of expectation.
Okay. So it might confuse you, but let me tell you, this expectation term is somewhat related to your probability. Okay. So expectations, I have a very good example with that. Will you mind posting this query in the forum, and in the next class I can go with that the solution I have with that example. I can deal with that. So will that be fine? Because if now if I'm going to tell you, I'm pretty sure you'll not be able to just get it with the theoretical thing. So
Okay, I'll
yeah,
post it in the forum.
post it in the forum, and I'll definitely go back there. And if not, then I can give you the example over there itself. If not in the class, then there itself.
Okay.
So I hope like today's session is clear, and it's already 4 o'clock. So
Just one doubt. Hello.
yeah, please go ahead.
Ma'am, actually, what eigenvalue represent for that matrix?
Sorry, what? Eigen?
Like
Yeah.
for that matrix, we have the eigenvalue 1, 3.
Yeah.
So how can we interpret that 1, 3? What is represent that for that matrix?
Okay. So that is the unknown values which need to be found. So eigenvalues and eigenvectors in a matrices, these are the functions which we needed to find to do the further calculations. So now the question will be what kind of calculation. So I'll give you one very small example. This, maybe you have not heard this terminology. There's something called principal component analysis. So in that, we have to I am a interdisciplinary background student, and I deal with images, satellite images. So what we have to do is in satellite images, and I'm trying to explain you in terms of application purpose. So how this lambda is being calculated and why, what is the significance of that? That is, I have interpreted your question is. So with satellite images, we have to reduce its dimensionality. Dimensionality means the data on, and the data will always be in the form of pixel values, and the pixel values is nothing but just the numbers. So in short, the satellite images will be having some numbers, so I need to reduce those numbers. So to optimize those numbers, we have to identify few functions. So how that can be done, we do with calculating eigenvalues and eigenvectors. So this is the significance, and this is the the most layman thing I can try to let you know. So this is one application of this.
Thank you.
Yeah. Okay, then I'd like to end the session, and thank you so much. So we'll see for the next class.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you, ma'am.